Welcome back, chat. Today we're going to jump in and just knock out some problems from 3.2 using all these fancy formulas that we had from yesterday. Now, if you guys have all those written down, it means that when I slide over on this screen and these are no longer visible, you'll still have them, right? Okay, so if not, I'll give you one more second. I'm going to start working my first example right here, and like I said, we have a bunch of them, and the cool thing about doing it this way is that you don't know necessarily which formula it is. We have to think that part out. So I'm just going to say, instead of just example A, B, C, whatever, I'm just going to call this examples because we're going to have slightly different focus and drive. Okay, today is straight up all examples. Sean? Yep. Okay. Now this first one, we are going to write a little tiny bit of stuff, but nothing too crazy. On our first example, which I guess we can call this A, we have a short sentence. A car accelerates from rest at 3.5 meters per second squared. What I want to know is how far will it travel when it is moving at 25 meters per second. All right, I'm going to give everybody a second because I want to make sure that we can pick apart this information and really make sense of what's going on. All right, first thing, I cannot, I mean I probably could, but it's not worth the effort on my end. I'm not going to require 100% that you do the no format in your notes. I would strongly encourage it, however, like you should realistically. It will help because you're going to have to do it on quizzes and tests. First thing, we know some stuff about this, and let's work these parts out together. So we have some known info. So here we go. And I never remember, it's going to be interchangeable between know and givens because I don't remember which one I do in which class. You do you on that. Okay, so for this, that's not what I was needing. Do you guys know your numbers? Okay. Oh, my sheet's over there, but I'm just going to trust you. We have 12 in here. I'll be 13. What number's Abigail? You guys, why would you know that? I'll be Abigail. I'm number 2 today. All right, number 5. That is Angel. Can you give me one thing I know? Okay, so what would you like me to physically write down? Because you're right, I do accelerate from rest at 3.5 meters per second squared. Love it. My initial velocity is written in here, but it's kind of hidden through the language. If it's at rest, what's its velocity? Indeed, 0 meters per second. Cool. How about number Rafa? Can you give me something else I know? Okay, notice a very intentional gap here. Acceleration is 3.5 meters per second squared. And that unit, if you are still uncomfortable with it because the units get strange and they'll get weirder than this is one that we can actually make sense of. After 1 second, how fast should I be going? If I increase my speed at 3.5 meters per second 3.5 meters per second. I speed up 3.5 each second. Means at the second, how fast am I going? 7. We just doubled it, right? And add 3.5 every single second. That's all that's happening. That's that meters per second, or meters per second squared. Why did I leave an awkward gap here? Say it again. Oh my goodness. What is the final velocity that we need? Hey, 25 meters per second. And now we get to start thinking about it. There's one more piece of given information that I know. What am I actually asking us to find? And I'm going to write my find here so I can have all the work show. And I'm going to leave space because I think there's one more. Number Abigail. I don't have a good Abigail impression, I'm sorry. I think I'm trying to find how far it will travel. Now that doesn't mean a ton because I just read what was written on the board, but that's okay. Barsega, can you tell me what this actually is asking me? How far will it travel? Final what? What does this one represent? Good. I am after the final position. We don't know it yet, but we will. Okay, last little thing. There's one more piece of given information that, man, Angel, your number shows up like 80% of the time. I keep skipping you so I can call on everybody. Number 12 is who? Rafa, but we're just going to go Riley. What's the last given information that I know? And it's not really written here, but we get to pick it, which is super nice. So anybody, if you are struggling with this, that is totally okay. Anywhere in here do I tell you a time? But I know that we're solving for this, right? Like we're trying to find its initial position. This equation is out for now because we don't have time. So all I need to do is look up here and say, man, if there's another way that I can get final position, we can probably figure out what we're missing. Hey, this does it, right? Do I have VF and VI and A? And I know what 2 is. What else don't I have yet, though? My initial position. And here's the cool thing. Do I ever tell you where it starts? So it is your choice to pick this. Riley, if you get to pick the starting location in meters, how would you want to write it down? What's the easiest place you could start at?
0.
Good. 0 meters. All right. Now, we've done 2 things just throughout talking about this. One, I hope that conceptually that little 3.5 plus 3.5 every second helps to clarify what acceleration is really talking about. But second, when we see what we need to find and we realize that we don't have time, we lock ourselves in. There is a singular equation that we can use. In past years when I've taught this, this is the only version of the equation that I gave, and I said rearrange it yourselves every single time. Bless you. I think that you guys could rearrange it, but I'm more concerned with can you use it rather than rearrange it necessarily. So let's lock this in. I'm going to call this equation / scratch, and this is going to keep changing because I can't decide the language that I like for this. If you guys have a suggestion, I'm happy to hear it. Work makes sense for me, but work is a specific physics thing, so I'm trying to avoid that as much as possible. All right. Huggins, what equation should I use? We're going to do the following to make this easy. You don't have to label yours, but I'm going to say here's equation 1, 2, 3, 4, 5, and 6. Which equation would you like to use here if we're trying to find final position but don't have time?
4.
So careful. What's the very last variable in equation 4? 2. Okay. So I don't have my color coding here because there's like so many different variables. But I know the equation is just going to be x sub f is equal to vf squared minus vi squared over 2a plus x sub I. Now, can you guys tell me what the units should come out to in this if we're finding a position? It should be meters. And just to check real quick, we didn't do this yesterday. Don't write this down. You don't need to. But how is velocity measured? What's a unit on velocity? Sorry. So if you square it, what would it be? So careful. It's not meters per second. If we took meters per second and squared it like this, what would it spit out at me? So let me rephrase it. To square something, do you agree just means this? And how do we multiply fractions? Straight across. What's m times m? M squared over s squared. Now I'm doing this because I want to verify that we didn't get goofed up. I know that we didn't, just so you're aware, but this is the unit game that's super valuable to practice, and this is a nice place to do it. I know that this numerator is going to come out in meters squared per second squared, which means nothing to me. When I divide, I'm dividing by acceleration, which is in what unit? And let's just do the little math here. Fraction over fraction. What do you want to do? That didn't work as well as I wanted it to. Take the reciprocal, right? Or multiply by the reciprocal. So if I do that, I just want to check here. That'd be seconds squared over meters. They gone and they gone. Is this going to come out in meters like I should? this unit game becomes so important. Right now I know that it's going to work, but it's good to be mindful, very demure about these sorts of things. I don't like that one. Not a big fan. All right. Well, let's plug and chug. Help me out. What am I going to plug in for VF? 25, and we're going to have to square that, which is the same thing as 5 to the 4th, which is easier for me to think about, minus, what's VI squared? So rather, what's VI is just 0 squared over 2 times, what's my acceleration? 3.5. And then finally out here, it's ugly, but it's just plus 0. This is inconsequential right now in this problem. I would encourage, especially on the first step, probably worth your time to write it down though. All right, so 5 to the 4th or 25 squared I think is 625. Somebody could verify that, that'd be awesome. I'm like 99% sure, 625, okay. Minus 0 is still just 625 divided by, what's 2 times 3.5? 7. Before you guys will just type this in, do me a quick favor just for the it sounds rude, it's not just for the entertainment, I just want to check. Divide it by hand. Do your division. Show me you remember how to divide. Do the long division by hand. I promise this isn't in vain for almost all of you. We will be dividing again in a different course, so it's worth it just to hit it here because it's a nice reminder. Did you guys all learn to divide with these symbols? Okay, does 7 go into 6? No. Do you write the 0? Okay. Does 7 go into 62? How many times? 8. That gives me 56. Really important here. I'm going to put parentheses around it. What do I do with this? Subtract it. Now I'll subtract that. I'll borrow the 10. Looks like a 6. And in the words of Snoop Dogg, how should we drop this? Like it's hot. Down. What? Down. And let's see, 7 times what goes into 65? 9? And that's 63. And again, the poet laureate tells us how?
Drop it down low.
Oh my gosh. Okay. Now what happens? We had a 0? Okay.
Oh wait, no.
Oh, like you want me to add a decimal because now we're going to round.
Yeah. There you go.
7 goes into 22 times, and we'll go one more. I think it's 8, right? What?
Oh, yeah.
I think so. Okay. Boom. Am I really going to make you long divide on a test or anything? Not in this class. All right. Beyond that, we get our answer then. X sub f is about 89.28. And what's my unit? Meters. Now looking at it realistically, should I really go to 89.28? How many sig figs in the one with the least that has values? They have 2, right? This has 2 and this has 2. So that should have 2 when we write our answer maximum. If you give me 89.28, I'm not going to burn you. But help me out with the context. I already don't remember the problem. They do something. How fast are they traveling? $25 what? Meters per second. When they are, or when they have traveled, how far? 89 meters. Boom. Okay. If you have the list of equations in here, this class feels less like true math and more just like plug and chug type math. is this, give me a scale just where you feel 5 is, I'm like awesome, I could do this on my own if I had to. 0 says, uh-oh, this sucks, I wish I dropped physics, or anywhere in between. You will not hurt my feelings. If it's a 0, it doesn't necessarily mean you really wish you dropped, but maybe you do. Okay, let's do one more with your groups, and then I'm going to give you a head start on it. Now, on this one, I want you guys to open up your books. I'll give you a second to do so. Page 72. What does demure mean? Classy? Reserved, modest, and shy is what it really means.
Modest.
A demure knee-length skirt is permitted per our dress code. Cool. And I just want to show you guys that it doesn't make sense. I don't know if it was this class who talked about it. Bombastic means high-sounding, but with little meaning. You can speak bombastically if you're a great speaker, and like if you listen to somebody who's good at speaking, give a speech about something that they know nothing about. If you've ever read 1984, double talk is like the language. You can speak bombastically by changing your intonation to make it seem as though just possibly you are on the epiphyse and finalization of like human knowledge. I said nothing, but it sounded like it was important, I think. That is bombastic speech. How do you look at somebody in a way that is high-sounding speech? That's right, you can't. Ugh, I hate that one. Sorry. Thanks for letting me vent. All right. So, a new problem. And Abigail, if you don't have your book, I will hook it up. We are going to do another example, but instead of making you guys write it all the way out, unless you want to, we're going to do example number 23 on page 72. I'm going to take a picture of it as well so that you guys can see it. But I want you to be able to read through it in your book. You do not have to write it down. Right now, I'm asking that you guys try to solve this problem. I'm going to copy and paste. Right, I'm going to give you guys a head start. If you need me to help with the givens, I certainly can, but I want you to try it first. What I typically do is, it's a really bad habit, I typically don't even read through the whole problem and just start writing down given information. Terrible habit of mine. You should not just do that. You should read through it once at least to understand you know what is going on, and then start listing them. But I'm going to give you guys a head start. So Abigail, if you want to work this one, you can pause it, and you are going to see like detailed work, maybe without a ton of talk through, in 3, 2, 1. If you can get to the givens here, and you realize that the question's asking us to find time, this other part, as long as you have these equations available somewhere, you're going to be golden. We need a single equation that relates final and initial velocities, acceleration, and time. Now, most of those equations over there have positions on them as well. Do we have positions given? So let's just check. Right off the bat, this one's kind of opaque, but that's all right, I hope. Garbage, can't use it. This one has position, can't use it. This one has position, can't use it. This one has position, can't use it. This one might work. And it turns out that 6 is really just a rearranged version of 5. Does this equation right here have final, initial, acceleration, and time? Let's use it. That's it. That's our work through with this. So you now get the privilege of calculating out this guy, but you're solving it for what? T. It is entirely up to you. I think most of you guys will most likely plug in numbers and then solve it. Feel free to do so. I'm going to give you a head start because I'm going to solve it and then plug in numbers. Cool. I'll give you a head start though. So 2 things. We're going to come back together and I'm going to ask you guys some questions about that last one, or the new one here in a second. But I want you to compare and see if either looks neater, and there might not be a right answer, and that's okay. If you look at number 23 that I made you guys work on your own, I think most of you plugged numbers in first. Is that true? Okay, if you want to, that's completely fine. But I do want you to compare. If you rearrange this equation without plugging in any numbers, I think the majority of the time it's going to come up cleaner looking. I'm not going to require that you do it. This makes the unit game easier later on, but it also maybe clarifies kind of what's going on and gets you more familiar with the notation stuff. 8.8 seconds on number 23. Did we all get that? 8.75 seconds? Cool. And then it takes 8.75 seconds for the person to slow down before they move back down the incline or the ramp, whatever you want to word it. Questions about this guy before we look at the next one? Okie dokie. So, this problem, it has the word challenge in front of it, which makes it seem so scary, but I don't think it is. Now, I didn't include the picture for this. That's okay. I hope it's okay. You guys have the picture that's in the book. It's just the cars and an arrow, right? That's it. So, let's run through. What do we know? Okay, what else? All right, we know the acceleration is what? Now, here's something that is worth thinking about, and it's up to you entirely. What direction are they moving? West. Now, typically, west would mean what? Negative acceleration, negative velocity. Is there any part of this problem that you read through that goes, oh, but they're going to go east at some point? It's weird to do, or maybe it's not weird at all. Can we just call everything positive then? Just say west is a positive direction? We can avoid it. Okay. I know the acceleration is a screaming 0.22 meters per second squared. Okay, got it. What else? So for the picture, remember here's x sub I with a car. We're going to make it pick up because that's easier. Then it goes this direction, and it ends at x sub f, which is just the same pickup over here, right? Is that right? Beautiful. Gosh, he's good. All right. That's it. That's the whole picture. It doesn't really add anything to it, but they include it for some reason. Now, we know they're traveling west. We're looking for the what? Two things, I think, this time. I'm looking for their initial velocity and their initial position. So I'm going to write that down here first. Find x sub I and v sub I. Now, no particular order there, just so you know, because we're going to have to find both of them. But let's see what else we know. Gosh, there's a time in there, I think. Time is 18.4 seconds. Not 1.84, 18.4. There's one more known things, actually, here. Ooh, I know their final position. Cars velocity. And I'm wrong about something, but that's okay. What is their final position? 350 meters. And I want to reread that last sentence real quick. Do we really have two things we're solving for? Because I read and when I read it. What was the car's velocity at, not and, point xi? So I don't really need to find their initial position. They're just asking me for the velocity at that point in time. Now, to solve this, instead of just erasing, because I want to make sure that everybody knows I made a mistake there, we know their final position. What do you want to call their initial? Oh my gosh, that'd be so nice. Let's do it. X sub I is 0 meters. Now, we're golden. Maybe. I'm stuck. If I want this formula, and we're going to run into an issue real quick. Let's just try this. I'm going to state my equation in my Scratch, because maybe we got to be a little clever for a minute, which is awesome, and we should all strive to be clever all the time. However, I need an equation that relates acceleration, time, position, velocity. And if we just stick to the number convention, I'm just going to slide this way real quick. We need an equation that relates acceleration, position, time, and velocity. Any options? Number 4 seems to do it. Here's an issue, though. I agree with you guys wholeheartedly. Unfortunately, what am I trying to solve? I need my initial velocity. Oh, will that one work? Let's try it. Okay, so I've already lost it. X sub f. Nope. We used number 4, right? I don't have them written on my page. Somebody read it to me. X sub f equals x sub I plus VIT plus 1/2 AT squared. Okay. Now, we're trying to solve this for VI. Cool. I think, and I'm going to slide back over just to check, I'm okay with 4. This is one that I told you that we can rearrange if you want, but we didn't do it as a class. I'm going to rearrange this before I do anything else. Like before I plug in values. I'm trying to solve for what here? V sub I. So I'm going to show my work a little bit differently. To isolate V sub I, what's the first thing you guys would do? I didn't hear you. I'm sorry. That's okay. What'd you say? You could divide by V sub I. Here's my issue. You're allowed to, just so you know. Having it in the denominator doesn't help me, though. Because I don't want it to be something over V sub I. I just want it equal to itself. As I look at this, I want to subtract some stuff first. And I'm going to try to do it like this. Can I subtract xi from each side? And then at the same time, can I subtract 1/2 AT squared? That means this will be gone and this will be gone once I do this. And let's just see what shakes out. So we have, on our next line, it looks like x sub f minus x sub I minus 1/2 AT squared, all divided by nothing yet, just kidding, equals VIT. To isolate or solve for initial velocity, one more step. Totally, what do you want to divide by? Both sides by time. I'm good with that, so I'm just going to say divide by time here. And it looks like we now have the following. X sub f minus x sub I minus 1/2 AT squared, all divided by time, and that's how I get my initial velocity. If the fact that we have a 1/2 inside of this fraction makes things ugly, is there an easy remedy for you? What might make this look nicer instead of 1/2? Let me rephrase that. Instead of writing 1 divided by 2 for 1/2, is there another way you could write it? If you want to write it as 0.5 to make it look nicer, you're more than welcome to. Now let's just see if this works. Heads up, if there's ever a situation where we take a wrong step, I'm not going to call you out on it. We're just going to figure it out naturally, organically. But let's try. What's x sub f? So we get 350 minus x sub I is 0 minus 1/2. Acceleration was 0.22. And time was 18.4, and we're going to square that. And divided by what? I think I quietly heard time, but I'm going to write 18.4. This is pretty calculatory of a problem, it looks like. My advice, I want everybody in here to type this into your calculator. I want to see how many different answers we get and clear up any calculator confusion. Yo. I did write t instead of v sub I. Notice, typo. I need v sub I, and for whatever random reason, I changed it to t right there. Good catch, Mickey. I would have noticed. I probably wouldn't have noticed. I would have just wrote my answer with the correct context anyway. Cool. Make sure you type it in, because I want to see. Okay. So you can type it in. Yep, I want both you guys to type it in. I want everybody to type it in because we get wonky calculator stuff. I'll also type it in.
What'd you get? No, on the paper I got a different answer.
What'd you get? I do not get 1414. Okay, so check this out. This is always fun. I heard 1414. I heard 16.9. Give me another one. 347.9. Any others? 36.2. Love it. All right. So one of these is right. Here's what I'm going to do. I'm going to wait till Nick gets it. I'm going to steal somebody's calculator. There's a couple ways you can type these in. I'm just going to still use this here. Do you mind if I dig through your work? Can I show your stuff? Okay. Mistakes are good. Just for the record, because everybody will make a mistake somewhere. You guys have that calculation written down on your page? Okay. So we're going to look at this work on this calculator and see what happened. All right. So I need to pop into the right spot. Looks like it's probably starting 0.22 is in our problem, right? Okay, so you're doing every little part differently.
No, I did it in the whole.
You did one whole expression?
Yeah. Go down. Right there.
Right here, okay. So, let's check this out. Because your calculators are really good at math, but they're also really dumb. Just so you guys are aware. In this expression, 350 minus 0 shows up, right? 100% it does. Then you subtract from that 1/2 times 0.22 times 18.4 squared. And then all that gets divided by this. Now, here's the issue. Your calculator only understands exactly what you tell it. Division happens very last in a step, right? Not quite. PEMDAS says division and multiplication happen before addition and subtraction, right? When I see this typed in, this is simply in your calculation what it's telling me, and I'll just rearrange it up here. What I see typed in is exactly this. 350 minus 0 minus 1/2 times 0.22 times 18.4 squared divided by 18.4. This is what your calculator thinks you just did. Now, it did that because you didn't specify. If I say 3 plus 5 over 8, that's exactly what it's going to show up as. If I want it to be 3 plus 5 divided by 8, we add these guys. So, this is a really common, I don't want to say error, but kind of. It's an easy one to make. I'm going to type this in. You got a very different number. Let's check it out. Okay, not just your answer, but I want to look at this specifically. If you're typing this in, your level of comfort with your calculators is going to vary wildly between everybody, and that's okay. My advice, if you struggle with it and getting the right number, so anybody that got something other than this, I would say you should do the following. When you type this in, treat it in two pieces. First thing I want you to type in on your calculator is do the numerator. 350 minus 0.5 times 0.22 times 18.4 squared. Pro tip for you. To square a number, there's two ways to do this. If I need 18.4 squared, I just typed in 18.4. To square it, you can use caret to get to the exponent and then put in a 2. Or alternatively, let me get out of here. You can also just use this lovely button that says square or x squared, and it will do it. Okay, in the numerator, when you do 350 minus 0.5, like just the top, what do you get? And I'm going to verify that you get what you get. $312.7584 is what we're after. Okay? Now, this still needs to be divided by what? Do them differently and take the time to write it out. You can now just hit divided by 18.4. So here's that same number divided by 18.4. And we get 16.9977 blah, 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 blah. 17. Now, 17 watts. Meters per second. Okay, at point xi, the car is already traveling at 17 meters per second. That's all that's going on. Cool. If you want to type it in a single big stroke, you can, but you have to add parentheses around the whole numerator. Cool. All right. I don't know that you'll finish this entire assignment tonight, but here's what I'm going to do if How long expected out of class? 40 minutes. So I'm going to say spend 40 minutes on this tonight. Whatever we don't get through, we'll do a couple more tomorrow. Your homework. And I'm just going to type it up here. Your homework tonight is going to be homework 3.2. So here we go. Today's the 24th. Cool. That's not what I meant to do. What is going on here? That is what I meant to do. Okay. So let's see. 9:24. We just did physics lesson 3.2.3. Physics lesson. I'll spell that correctly in a second. Your homework is going to be homework 3.2, which you will find waiting on page. It starts on 74. It's actually all in 74. I want you guys to work through 32 through 35 and 38 through 40. Cool. PH. Awesome. I will go ahead and save the video and upload it. One of you guys, will you, just in case, take pictures of this? You can go grab your phone. Will you take pictures and send it to Abigail? Cool.